Hello, everyone, and thank you for coming to our webinar from Sky to Mine. Today we'll be talking about drone technologies and drones in mineral exploration, and we'll be talking only about real-life use cases. And our guests today will share their experience in using drones for mineral exploration. My name is Alexey Smirnov. I'm regional director at SPH, and today I'll be the host. And yeah, as Sabina said, please leave your questions in Q&A section. Just before we go to our captivating presentations about drones and mineral exploration, let me say a couple of words about SPH engineering for those who are the first time today with us. We are an expert in drone technology development. We have been developing drone technologies for the last 10 years, mainly for surveying, data acquisition and processing, and for entertainment. Our product lines include flight planning and control software, such as UgCS and UgCS Commander. Also, we created a lot of technologies to integrate drones with various types of sensors, such as GPR or magnetometry or methane detector. Our data sharing platform, Atlas, which can be used for data sharing, for sharing all the data you've gathered with your drones and sensors, and of course our drone shuttle technologies. Who are our guests today? Let me introduce Jorge Negrette. He's CEO of Geodia Industries, and he'll be talking today about GPR, ground penetrating radar, and Trevor Grace, who is the director of AeroPhysx. So we'll be talking about airborne magnetometry. And we'll be supported by Alexey Dobrovolsky, who is our CTO, and Yanis Karush, who is our lead geophysicist. So these guys can also answer to your questions, so don't hesitate to ask us. Okay, it's time to move to our presentations. Jorge, please share your screen and let's go.
Okay, good day, everyone. My name is Jorge Negrette. I'm a geophysics engineer, COO of Geodia Industries. I actually want to congratulate and thank you for this actual wonderful invitation to be a host and one of the co-hosts in this webinar. This is actually an outstanding program that has been set up by SPH Engineering. We had the opportunity to be with them last week in Latvia with my team. And I'm really honored to be attending this as a speaker. We're going to share our actual experiences of more than 15 years in the field doing geophysics. Geodia is a geophysics company, which we actually conduct. I'm going to take out my video if it's okay. Well, let's maintain it. Which actually have been conducted several types of methods. We're actual specialists in GPR. We're very passionate about this actual instrument. That's what we're going to be talking about today. And we also carry out ground magnetics, drone magnetics, and BLF electromagnetics. We all use all these methods for mining exploration and for other mining solutions, which will not be part of this webinar. We're going to keep you excited for the next one to come, which would be on geomonitoring and geotechnical solutions. Following the program that has been established by SPH Engineering. So therefore, we really have revolutionized the industry by utilizing these wonderful instruments, which many years back did not have the capabilities of going to the depths of nowadays that we have accomplished, enabling us to find solutions for miners throughout the world in their actual conquest or exploration towards different types of minerals. We're talking about gold, we're talking about copper, we're talking about lithium, we're talking about coal, etc. And we've had the opportunity in Latin America to have plenty of contracts that will have actually fulfilled a lot of these mining solutions. That's just an overview of what Geodia does. We really believe in just making things new completely from scratch and relying on this wonderful instrument that has been created by SPH Engineering, such as SkyHub, such as PPF, which we're going to be talking about a little bit about them, such as the current radars available as far as GPR in the industry that have come a long way in the last 4 to 5 years. So, mining solutions. Today we're going to talk about the drone-based GPR system. And we have created a program in such a way where practical and logical wise, we're able to actually offer internationally clients, which are in this webinar. And I want to thank everyone that has been signed up and participating in this wonderful experience, where we'll be able to show you that this mining solution, such as drone-based GPR system, can actually resolve many aspects of your exploration program. So it would be able to optimize revenues while actually reducing some of your exploration budgets. So it can be used for exploration, which we're going to be talking about today. It could be used for geomonitoring, for geotechnical purposes, for the mining industry, for the oil industry, and for government studies. So why do we need to implement this drone-based GPR solutions? Because in the past, we could not access certain areas that were remote, that were impossible as far as security and as far as risk of anybody acquiring data in a certain area. So nowadays, we're able to go into areas that are remote, that were impossible to be analyzed and to be able to be explored and have a technical evaluation in the past. Apart from that, we're actually having the latest equipment provided by the leader GPR manufacturers that offer calibrated GPS georeferencing. In the past, this was a problem because you could only rely on GPS that had a 3 to 5 meter error. Nowadays, we can go up to 8 millimeters in RTK mode, or 30 centimeters, which is enough for GPR resolution. And we can able to provide the customers accuracy in their actual results, in their images, in the maps, etc., whether it's 2D and 3D. And of course, the advanced GPR software is available in the market nowadays. This has also been a long way. I remember doing work in Africa, in Congo, where I had to use a software for BLF that was really difficult. And when a new software came about in 2017 from a European software developer, I was quite happy to actually be using this in that specific geophysics method. So this is where we got to thank providers and manufacturers such as Radar Team Sweden, such as SPH Engineering, such as Radar System, where they have created and developed equipment that have by far really innovate in the market. This was not available in the past, and nowadays we can rely on systems that we're going to be talking a little bit about this as the components of the drone-based solution. Geodia has a history of over more than 100 contracts worldwide with 15 years experience with more than 50 clients or happy clients out there. So what are the essential components of GPR drone-based system? Well, you need a drone. You need a drone capable of carrying the actual sensor. And depending on the weight, you're going to use different drones. In the front of you, you have the Matrice 600 Pro, which is actually attached to, or the radar is attached to the Matrice, which is a Sobeco 70, which is a series which is called Cobra plugin. It's part of one of their leading sales in the world. And they have different models. We're not going to talk about the models now. We just want to share the components. So one of them is the GPR, one of them is the drone, and of course, the data logger, UgCS SkyHub, which is responsible to actually record the data being uplifted from the drone and the GPR sensor, and the TTF system, which is true terrain following. which is responsible to make sure that the aircraft, the drone, flies accordingly to a specific program created by the software, UgCS, the leading software in the world for drone. This, for me, is by far the best solution out there for this type of advanced techniques of mining solutions. This is something we have to address. This is really important, that where we're taking this to the next level is where everybody wants to be at, mining solutions, not only in GPR, but our next guest and speaker, Dr. Trevor Grace, will be talking about drone magnetics. So some of the solutions that drone-based GPR offers: mineral exploration, we're going to talk about this today, humidity analysis and monitoring, detection of underground tunnels, pipes, and workings, stability analysis and subsidence evaluation, horizons analysis and modeling, aquifers allocation and evaluation, geological findings. We have pretty much conducted analysis on all of these aspects throughout the world. We have focused really nowadays on departments of the actual markets of Chile and Peru. We cater to the mining companies such as Minera Escondida, Glencore, etc. I'm sure Mr. Hernan Velasquez could be present, and Carlos Prado from Geomonitoring, one of our strategic partners and alliances in these countries, where we have gotten truly amazing results, audited by international leading consultants. So in that sense, we've actually been able to highlight this actual GPR drone solutions as we actually listed on this slide. So some of our clients is Minera Escondida, Anglo American, Grupo Mexico, Correa Mining Company in Guyana, Gold, Touchstone Gold, Colombia, Terra Drone in Brazil, Glencore, Peru, Sijin Gold. So we have actually wanted to share this technology with most of our clients worldwide, and to offer them this solution so they can really bring some important information to their actual exploration programs. So by that, let's enter into the magnificent and amazing mining solution, mineral exploration area. And by that, let's talk briefly about principles and functionality of GPR ground penetration radar. What does this instrument and system do? It basically transmits and receives electromagnetic waves, which by the changes on the subsurface of dielectric constant or permittivity, which is related to lithologies, porosity, permeability, etc., and it ranges from 1 for air, 81 for water. These changes within the subsurface have an actual direct affection on the amplitude of the transmitting wave. And by that, it causes changes throughout the what it's called radargram. And that's one of the outputs from the GPR system. That allows us to actually see, analyze, and interpret these actual GPR radargrams accordingly for the different types of solutions. That's what the actual principle of GPR is and fundamentals. So let's get into this first case that was successful. And what I mean successful is, for many years, there has been resistance about the depth capacity of GPR. The manufacturers nowadays are actually obtaining, believe it or not, depths of up to 100 meters. Now, of course, resolution, as you go deeper, is going to actually be taken into account. You're going to have better resolution closer to the surface, but you still have enough and good resolution under 80, 70, 50 meters below to be able to provide the solutions that our clients are seeking. And this has been a breakthrough completely in this actual industry. What has SPH Engineering has accomplished? They have accomplished the program to fly accordingly the drones, that is very successful. The SkyHub data logger, which is great because it's lightweight, it's efficient, and is able to compute and to be able to save the data accordingly, along with TTF, because believe it or not, if you don't have an actual system that can control your topography measurements, and when you're in areas such as Chile, which is 3,000, 4,000 meters high, which we fly all the time, geomonitoring pilots are very experts in this, and also in Peru, up to 5,000 meters, believe it or not, we've acquired data successfully to be able to provide the proper interpretations to our clients. So this first actual radiogram was back where we had the drone, yes, but we actually, this was prior to TTF. So georeferencing and some of the areas were not the best, but we were able to define for this specific client in Colombia, the actual lithological contacts between the sands that were related to the quaternaries, more closer to the surface, to the first actual discontinuity at around 12 meters. And then this client was pretty much producing at 7 to 9 meters in an actual draga or dredge. Once we actually told them you have to go down to 12 meters deep, and actually successfully he did, he started to produce double. As you know, gold, alluvial gold, actually is hosted between this discontinuities for the actual, whether paleochannel formations, etc., and the specific geological setting that this gold is at. And apart from that, we were able to tell them at 35 meters, you have another discontinuity, but in this particular area is not so productive as the actual prior one. The next slide has to do with Guyana, another mining company, Gold, which actually discovered a big alluvial setting, and he wanted to know where the actual primary objective was. Where was this gold coming from? Through the usage of ground magnetics, which I'm not going to talk about magnetics because our Dr. Grace will be doing that. We were able to highlight, first of all, their current deposit. They went into that area, started to produce and go down at a mushroom type actual structure. So when we went with GPR, we were able to pretty much assess the deposit dimensions of this actual structure, not only in X and Y dimension or extension, but also a depth analysis. And we were able to tell them, hypothetically, you could go down to 2 to 3 times the current depth and still have productive layers of gold as we actually speak, due to the responses on the actual GPR radiogram. So it really was a tool that was successful to actually give them under subsurface diagram of what was going on and continue to produce accordingly. So what we're really telling here is that apart from this being, yes, backed up by academic and logical sense of geosciences, this purpose of these mining solutions are towards commercial outcomes. This is not a museum. This is providing our customers data that is logic correlated with geology, correlated with structural geology if necessary, so they can optimize whether is their exploration, drilling program, sampling program, or production front accordingly. So this has logic. This is about making money by providing correct and somehow correlated results. The next slide has to do with another customer in British Guyana. We've done a lot of work in British Guyana. Guyana now has a boom of oil. It is said to be the #1 revenue or a return country in the world, where it was nothing 2015. My friends in Guyana did not believe that this could be happening. 500,000 barrels a day. Now they're up to 5 million barrels a day, believe it or not, making it one of the richest oil deposits that have been found. So in this radiogram, we have an unconformity at around 4 meters. And this is where the miners were actually taking out gold and diamonds, but they were making a mistake because the truly more productive layer was at 17 meters, which was highlighted by the actual radiogram and drone GPR system that is actually nowadays a successful mining solution tool. The next one is a subsurface integrated target optimization. Many times the clients have issues of really where should I actually start doing my sampling, my drilling, my production front, whether it's a medium-sized, actual smaller miner or a medium-sized mining company. Where should I actually focus on a vast region that I need to actually create targets and provide resolution? That's where GPR mining solution provides. You can see an example on the left-hand side where we'd actually identified a vertical structure along with a horizon analysis and along with a feeding towards the surface as actually optimizing a sampling target allocation. In the left bottom side, in the right bottom side, we actually had a production front where the client did not know how many layers of horizons they could actually have productive up to 30 meters in depth. We were able to highlight this and we were able to pretty much give them a path and an actual direction of success of their mining front. This is for alluvial mine. For gold, we've actually conducted for copper, for gold. Here we have restricted time. So we basically have shown some of the actual successful results that we've actually gathered through our years of experience using this drone-based GPR system. So how do we go about using this data? Well, nowadays you have GPR specialized softwares. We use up to 5 softwares in Geodia. Prism 2, GPR Slice, GeoRadar Expert, GeoHammer, and MagLab GPR. This is essential, but of course you need experienced geophysics engineers that know how to utilize and provide proper protocols to have an actual calibrated data and also deliverables, which range from reports of every single, we have more than 10 deliverables depending on the actual area subject to study and the solution. And this has been some of the bottlenecks that I've encountered some of the clients worldwide. Well, we're interested, we're gonna buy the UgCS data logger, SkyHub, we're gonna buy the TTF, we're gonna buy the, whether it's radar team, GPR, but we don't know how to process the data. Now, this program that has been developed with SPH Engineering includes the actual wonderful and exciting news that we're able to provide you with processing services from now on. So you're going to be able to send the data to either SPH Engineering or Geodia directly, and with logical fees and proper deliverables, you're going to be able to have your data processed and proper reports allocated with the solution you need to provide, whether you're the final client or an actual consultant. We can do that for you nowadays. So the essentials for the actual components of the drone-based GPR data, what its essential is on the left-hand side, you need the components of the system, which is a drone. In that picture, you have MT-1500, manufactured by T-Motors, fantastic drone that is actually with a big payload capacity. It's uplifting a Sobeco 40, which actually is more than 5 to 6 kilos in payload. SkyHub data logger, TTF system with a radar altimeter. On the middle of the image is the grid design and logistics. This is essential. A lot of our clients, they don't understand what the direction of the lines they should be acquiring and at, what is the longitude, what is the spacing, where should they start and finish. We provide all that sort of information through our actual services and the logistics, because we have a lot of experience on this and we can guide you and tell you we think is this and that. And that's included once we're actually part of this wonderful family of geoscientists that really want to go to the next level in innovation and apply these mining solutions. And of course, the processing on the right-hand side and deliverables that you can see some of the images, which is AutoCAD, which is files DXF that have been implemented with highlighting anomalies within mining projects. I think I'm finished. Thank you so much. I really want to address again my gratitude and the honor of being part of this webinar. Geodia is now in a program which is extending internationally. We're going to be conducting some expansion towards the Middle East, based out of Dubai. Mr. Raj Kudupali, which is probably on this webinar, is our partner and director for international business development. I'm sure Squadron is present in this webinar, which is our new strategic partner and alliance in India. We're gonna really take care and cater for all these markets in the Middle East and in the Far East, and we're expanding also to Indonesia. We're already talking to individuals there. We really believe that this type of technology can be used in many solutions, and in this case for mining exploration. Thank you so much again. Thank you, Mr. Alexei Dubrovsky, Mr. Alexei Smirnov, and all the actual very professional and intellectual individuals from SPH Engineering. It's a pleasure to have to be here.
Thank you. Thank you, Jorge. Now it's time for questions. The first question from Dion. What was the drone average flying height? Namely instrument height AGL.
We normally fly at 20 or above meters of flight elevation from surface. This has to do with the terrain, and it has to do with the actual parameters of uplifting data. So in that sense, we really, every case is different. If it's canopies of trees, we would fly above the canopies of trees, and then do some filtering to be able to actually adjust the data. So as far as elevation, we're talking about 20 meters, and also for safety.
Okay, thank you. Also, one question from me before we get to question of Robin. What should be the first step for those who decide to start using GPR, drone-based GPRs for the mineral exploration?
They have to define what they're actually seeking for. Whether it's a mineral structure that is disseminated gold, whether there are veins, whether there are underground tunnels that carry mineral, whether it's alluvial paleo channels, they have to first have an idea of what they're looking for as far as mineral exploration, whether it's copper, actual porphyries, whether is knowing that they have capabilities of about 100 meters in depth. Cold actual seams, lithium layers that are closer to the surface. That's the first step to do. You do a preliminary diagnostics. From there, you know what your target is as far as depth, as far as dimensions. And then from there, you start doing a coverage plan. How many hectares I'm going to cover? How many, what is the resolution I require for that actual specific solution? How many lines should I actually uplift? So what that has to do with a grid design overall, to be able to make sure that your data acquired is efficient and you're fulfilling the mining solution you're after seeking.
Okay, thank you. The question from Robin. How much ground could you cover in one day in perfect flat terrain?
It depends on the amount of batteries you have. We can cover, depends, for instance, TB48S from a 3600 Pro will give you about 15 minutes in the air capacity, keeping it safe. So you have about 2,000, the velocity of acquisition for GPR is about 3 meters per second. So that gives you about 2,700 meters in one battery cycle. So that will actually depend on how many you want to obtain throughout the day. We have 5, 6, 7 battery packs. And of course, it depends on the conditions. We fly in the morning, we fly in midday. Most of the time is morning time when we fly in most of these actual complex topographies.
Okay, thank you. Next height related question. What is the maximum altitude to have accurate data?
Well, that depends on your, remember, if you fly at a velocity of, let's say you're using the Cobra SE40, which is about 110, 120 max, with a proper host rock transmission, it depends how much you want to, if you want to accomplish, let's say 80, then you have to fly, you fly at 20, then you're actually are going to have 60 under the surface. So you do your mathematical calculations depending on your flight elevation and your target underneath. There is some Excel calculations which have been created by SPH Engineering that once we get into the details of grid design, we can define those parameters accordingly.
Okay, thank you. Two SkyHub related questions. Does the SkyHub kit help when you have a vegetation cover over the area of interest? And second, where was it? It disappeared. It was about radar.
Sorry, Alexei, I typed the answer. So question
Okay.
is any of our radar altimeters compatible with GPR?
Yes.
Answer is all our provided altimeters are compatible with GPRs because they are working on the very high frequency, 24 gigahertz, and they will not interfere with low frequency GPR systems, of course.
Okay, thank you, Alexei. Question from Clint. Have you built a library of resource validations to speed up processing, or do you validate targets individually for clients?
Every single case is personalized. We actually have a cloud of actual data that we confidentially have in our system. We don't share any of this because we have confidentiality clauses with all our clients worldwide. And in the case that we have new protocols that we have to establish depending on the solution, then we go ahead and create them.
I can also add for this, currently in the world, there is a tendency to create such libraries to speed up interpretation. But up until now, there is not one like completed library you could use like for every possible case. So in general, currently, still for GPR, you need to do like individual tasks separately. It's really hard to generalize interpretation.
Okay, thank you, Yanis. Next question is from Helen. In the United States, we have FCC restrictions regarding which GPRs can be used. You likely encounter similar restrictions where you operate. How do you work within them or perhaps around them?
That's Mr. Alexei's turn because he's more familiar with FCC.
Yes,
no one low frequency GPR system with unshielded antenna is certified in United States. And actually, it is not possible to certify unshielded antennas in the United States at all because FCC requires that energy of GPR impulse should be directed straight down. It is not possible for unshielded antennas. I know that some universities and government contractors use not certified GPR equipment. They somehow were able to get special permissions to operate not certified equipment in certain areas, which are far from cities, military installations, and so on.
Okay, and I suggest us to answer two last questions. One about the weather. There are several questions about the weather, how the weather impacts the operations, or can you fly with all weather conditions and everything like that. And your climate and low pressures, does they affect your operations?
No, we through our actual partners in Chile, Peru, etc., we have measures. We have a complete data control or checkup list, where if it doesn't meet all the standards that are necessary to fly, we don't fly. That has to do with climate conditions, rain, etc., 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 etc.
Okay. So Yeah, that's not possible to fly in every weather condition. So, and the last question: what is the success rate and confidence level of this system in mineral exploration, and which minerals are the best suited? Is there any minerals that cannot be done with this? What about REE minerals?
In our experience, Geodia, our success rate is above 70%. 70% is better than zero. Okay, I always say that to my clients, always. So that whether you want to have an actual scrutiny and diagnostics and be successful at a rate that is above 50% and above 70%, then you're actually in the right path for applying the technology that is actually available for you. As far as what was the other minerals that could be, you always have to diagnose proper exploration with geologies. This cannot be disattached. You always have to all my geophysics engineers that work for Geodia, which could be present at this webinar, Laura, Daniel, Sarah, etc. They have full knowledge of geology to be able to correlate in a place where if there is no gold, why we're going to conduct a program there? If there is no actual lithium, if there is no logics to a certain mineral, then we don't do that. And we advise the client, no, you're going to waste your money. Okay, don't go there. Because it has to be synchronized and correlated to the proper mineral you're finding. What these solutions are providing you is more understanding of your inside subsurface to be able to maximize your time, minimize your budget, and to enhance your program. That's what really geophysics is about. And this technology, which is wonderful with drones and with data loggers and with control of elevation and with GPR and magnetics, is for that. So we have to be synchronized all the time with geologists on that. What was the mineral that they mentioned? Rare minerals?
Rare earth elements. The question was about those minerals. But in general, if you think about GPR, you must understand that with GPR, you map boundaries and you map areas that have different electromagnetic properties. And then you can link those boundaries and different areas by using boreholes. You can link them to various types of rock types. So this is not like there are some specific mineral type that cannot be found by GPR. It's just the GPR is designed for mapping boundaries, actually. So you can map various kind of minerals.
This is not a metal detector, okay?
Yeah.
This is a system that needs to be correlated with geology, just like Dr. Janice stated. This is boundaries and correlation with geological assessment.
Okay, thank you. Yeah, we have 10 more questions left. They will be answered in our recording. And
Alexei, may I comment a couple of questions, especially tricky question from Gianfranco about 20 meters elevation.
Of course.
So in general, I agree that 20 meters is too much. But together with Per Wikström in Sweden and Boden in their base city, we did survey over the frozen lake. And by mistake, we sent a drone at the altitude 20 meters. And we still penetrate through the snow and ice and approximately 8 meters of water. But in most cases here in Latvia, we didn't get any useful results when we fly above few meters over the surface. So I can imagine that it depends actually on the surface, especially on the top layer. If top layer consists of dry rocks, maybe we have a reasonable penetration even from 20 meters, but it cannot be a general rule. Our standard recommendation is to fly as low as possible in particular conditions.
Yeah, thank you.
We actually did a work in Peru for Glencore, where we identified pipes, and we identified manholes, and we identified flows of humidity flying at 20 meters high, and they were correlated with all mappings and with all schematics that the actual mining company had, and we were successful on that. The resolution was not the best, but we will still be able to actually highlight them in the radiogram. So we have done this, and we have done it. Every area is different.
Yes, it depends. In Peru, a few years ago, I spent almost 1 month in Peru with archaeologists, and sometimes we had very good penetration in areas with very dry sand, even flying pretty high over the surface. It depends, of course, but general rule is to fly as low as possible, of course.
Correct.
Yeah. Okay, before we switch to magnetometry, just one slide from me to highlight what airborne GPRs do we have. Several models with tender frequency starting from 50 megahertz to 1000 megahertz, and penetration depth also from 0.5 meter to 20 to 30 meters. And you can detect objects as small as 7 centimeters and up to 1 meter. And of course, as Jorge said, you can fly really low with our true terrain following kit, which also help you to get more accurate and more precise data. So the models are the following: that's various radar systems and their various radar team GPRs. And also this year we integrated Mali Geodrone GPR also with our software and hardware. So, and now it's time to move on to airborne magnetics. Please welcome Trevor, Dr. Trevor Grace. Trevor, you can share your presentation.
Okay, my name is Trevor Grace. I'm a director of AeroPhysx. We've been in the airborne geophysical data collection business for 45 years. We started out with fixed wing and helicopter. I've personally flown and processed probably in excess of 11 million kilometers of airborne data. About 3.5 years ago, we started looking at the drone technology. The motivation we had for that was, if you take most countries in the world, not all countries, but most of them, there has been regional coverage of aeromag and radiometrics. Normally at line spacings from 200 to 1 kilometer, and some of the older data sets at 1 mile. But the common to all of these data sets is where my interest is, and that is in mountainous terrain. Obviously, you can clearly see if a fixed wing aircraft is flying towards a mountain range, it needs to start climbing way in advance.
We are seeing your first slide, the title slide.
Okay. Okay, let me just take it from the slide, and then I'll just amplify on it like that. I've covered there where we fly in rugged and mountainous terrain. For this, we use the UgCS terrain following. What we found with UgCS is it is no doubt the most superior terrain following and drone control software that we've come across. And we've been working with UgCS for a number of years now. In fact, I think their support division is probably pretty upset with me with the amount of queries I make over time. But we concentrate mostly on larger surveys. Now, here's an example. This was taken in Zimbabwe. Underneath is the regional data, which was at 1 kilometer line spacing. And this was over a platinum dark field, and we flew the drone mag over that area. And you can clearly see it's just an amazing difference. And as a matter of interest, this is a platinum deposit, and it has been developed starting last year into a major platinum mine. I find it quite exciting that a lot of our projects end up going to the mining stage, which is very pleasing for me. If you have a look at the advantages and disadvantages of drone mag. It's quite clear to see. I'm sure that everybody that's been involved with drone mag can more or less know the answers to all of these. But there's simply no comparison between fixed wing traditional data and drone data. The difference is stunning. There's just no comparison. If we move on just very briefly, we're finding that our clients, and we have a list of fairly major mining groups. In fact, we are busy in the process of being appointed as a service provider for Rio Tinto in Africa. We hope to conclude that arrangement within the next couple of weeks. But we are now reflying areas within mining areas and also in greenfields terrain, mostly in Africa at the moment, but we have just opened a Canadian office. And the reason for all this reflying is as indicated in this slide. It's taken the quality of the data to a next level, and very important to the mining houses and the clients that we work is the safety and risk assessment. If there is an accident, there's no life at risk. And unfortunately, during my career, I've seen many of my colleagues killed in accidents, in aircraft accidents, because of the low flying requirement, and particularly in mountainous terrain. That risk is now gone completely, which is very important to our clients. Just a brief slide there. What we found is we started off with DJI products using the M600. We found it very inconvenient because we're doing fairly large surveys, mostly in remote areas. And to carry 60-odd batteries and the charging stations with the endurance of no more than 20-25 minutes was the ground side of the operation was getting more onerous than the actual airborne side of flying the drone. So we've moved on to long endurance drones that have 50-70 minutes endurance. And in certain countries where the law allows us, we fly in lines up to 5 kilometers long BVLOS. We cover very large areas. We've just come back from Guinea in West Africa, where we flew 5,000 kilometers of survey. And we did that in less than 2 months. We're using the mag arrow at the moment. We are looking at a few other options, but the mag arrow is a very decent piece of equipment. Limitations, side wind resistance. During the turns, if the wind is suddenly crossed, you could have some swaying. And during normal flight, there is an oscillation of the unit in the air, which then requires us to actually have a compensation method to deal with this, otherwise the data quality is compromised. But the mag arrow has everything contained within the unit, so it's actually completely independent of the drone itself, which is very, very useful. We flew a test area over an old mine that has ceased operation in South Africa. It's called O'Keep. It used to be a copper mine. It's disseminated copper. We flew mag, and we actually, I'll just briefly touch on it because it's not part of this presentation. We also flew drone EM. It was very successful. The options were bought out by an Australian mining group, and they are now developing the mine even further. To sum it up in very simple terms, the boreholes that they were drilling were not deep enough, and the main body was about 30 meters deeper than their deepest borehole. And we actually mapped and detected the body completely. So again, a very great result for us. And it's now been developed into a fully operational mine from a mine that has been sitting unused for the last 30 years. This is a study we did at Vedanta in South Africa, very, very mountainous terrain. It was flown with a crop sprayer in 2015. That's an example of a section of the data. We flew it at using the drone over the same section. and you can see the difference in quality. This is purely to the control of the height. There are sheer cliffs, very rough terrain, and of course the drone handled this very, very well, so we get the superior results. As a matter of interest, in this area we also used drone EM, and it was also very successful. This is a very interesting example. This is part of a project that we did in Guinea. It's near the equator, so the magnetic field is very flat. With the mag arrow with no dead zone, it's a very big advantage in that we don't have to adjust the sensor angles, and we can fly in both directions without having any sort of problem. To give you an idea, this was for, as in the text there you see, it was for gold. The gold is very difficult to understand. It's in quartzite veins and it's non-magnetic, but luckily for us, it's associated for some reason with more magnetic material. So if you look in the north of that image where the red-white coverage is, that is where the actual quartz veins are concentrated. And in fact, just north of this, about 5 kilometers north, Anglo Gold Ashanti, a major gold mine, mining near surface gold, open pit gold mine. And it's in the same sort of structure as you see in the north of this thing. To give you an idea of the magnetic accuracy, those contours that you see in that image are 0.2 of a nanotesla. Now, another interesting thing is normally with airborne mag, you fly tile lines at 10 times the spacing of the line spacing to level the data. With drone mag, that becomes problematical because of what we call the postage stamp size of the sub-blocks. So we've developed a leveling technique which levels the data without the use of tile lines. So we don't fly tile lines. We use a different technique which we've developed ourselves, which relies on base station data as the first correction. Then we use overlaps of the postage stamps to each other, and then we use central points within the postage stamp collection of that particular day relative to a value that we've taken for that area. And it works very well. As you can see, that's 0.2 of a nanotesla contour intervals, and there's no discontinuity visible in the data set at all due to any leveling errors. Okay, with our experience, as I mentioned, we do fly small areas. You know, for example's sake, we just finished a survey a couple of days ago, which was only 100 kilometers in South Africa. But our speciality is larger surveys. With that comes all the associated problems of the logistics, access, being able to get the crew there, safety, health issues, etc., etc. If you're flying in remote zones, for example's sake, I use Guinea as example again, we are literally in the middle of absolutely nowhere. There's no help, there's nothing that can assist you. The internet services are very, very random. You normally have to move to a point to get a connection. So experience, mission planning, experience of the crew is all very, very important. Our pilot for this particular survey has over 1,000 hours of drone mag flying experience at low level. One of the things that we found ongoing is SRTM is very often nowhere near good enough for terrain following if the terrain is starting to get hilly or mountainous. So we've added to our product list, we do orthophoto DEM creation. And if we have fairly rugged terrain, we insist that the client does this as part of the package, and we use that model for the terrain following. Even at that level, a number of years ago, flying at Vedanta, we had a drone accident. when we had a 2-meter accurate LiDAR data set that we were following. When we investigated the cause of this accident, it was quite clear that we had an overhang in the gorge, and the waypoint at the bottom of the overhang was too close to the edge. And when the drone went over the edge, it tried to backtrack to the actual waypoint and impacted the ground. So we developed something called the bubble technology. I'm going too fast there, I'll get to that. If we go to the UgCS mission planning, as I mentioned earlier, we've moved away from DJI. We have 2 M600s, but we use them as backup drones. We've moved on to the really long endurance drones, and it's actually completely changed the game. For example's sake, in Guinea, it can sometimes take us 2 or 3 hours to move to a new takeoff point. Simply no access. So this has solved a lot of those problems. So we are moving more and more to pixel-based systems and long endurance drones. And we mainly fly BVLOS out in Africa. And as I mentioned earlier, we fly in lines up to 5 kilometers long. This is a job that we're just about to embark on in the next couple of days. This was a very unfortunate incident in South Africa. A very large factory with insecticides was caught fire, and all the insecticides seeped into the water systems and into the rivers, and has gone down to through the rivers and on the underground water tables into the ocean, and it's poisoned the whole area. So we are detecting the dikes and faults to try and track the flow of the water from this actual incident. Where that blue dot is, just there is where the factory was. And unfortunately, we cannot fly over the highway. It's a major highway. So we had to break the survey into 2 parts. But that's the reason for this survey. And again, as you can see, the control of the 3 blocks is easily done with UgCS. It's just amazing flight control software. This is an example of the Ortho DEM we flew in Guinea. This was for a Turkish company. That was about 2,000 kilometers of flying. We flew a DEM first, and then we flew the MAG afterwards. Our flying height in this area was 25 meters. 25 meters above the top of the vegetation. Some of the trees in this area are pretty high, which causes a problem. One of the major problems we have in these areas is cell phone towers. Even though it's very remote, they do have towers. For example's sake, in the 2,000 or 3,000 kilometer area, we might have 4 or 5 towers. And because of this remoteness, these towers are generally 50 to 80 meters high, sometimes 100 meters. And we need to map them, and we need to lift the flying height over these towers. So therefore, a survey by the team driving around the area to map these towers and asking the locals where these towers are is part of the problem that we need to deal with. Going back to the accident where happened, that with Vedanta, you can see there on the top right-hand side, that was the cliff face where we impacted, where that 35-meter horizontal line was the point of impact. So what we did was we developed what we call bubble technology. What we do is we build a virtual sphere around the drone of a given height. The flying height of this survey was 35 meters. So we built a 35-meter virtual bubble. And wherever that bubble touched the surface of the Earth, we adjusted the surface of the Earth to move the drone away from that to a distance of 35 meters. So you can clearly see you've got the surface of the Earth, then you've got the flying height, and then you've got the bubble technology shown as 3 different layers of graph on that image. We've since flown thousands of kilometers, including this whole of this particular mountainous area, without any incident whatsoever. Down below, you can see the effectiveness of it. You can see flying in this terrain. Clearly, we go up and down into the valleys, no problem at all. It's something that we're quite proud of, and up until now, it's proved faultless. We have not had a single incident. So it's working very, very well for us. As I mentioned earlier, when you fly in with the mag arrow, you can have oscillation, which is very normal, even in very light wind conditions. We're flying at 9 meters a second, and we find that at that speed, you get in a little bit of lift on the nose, and then a drop, and then a sideways swing left and right. It's not very great, but it's big enough to cause that oscillation that you see in the red. So what we've done, the suppliers of the mag arrow geometrics do supply compensation software. I've used it. I find it very, very difficult to get decent results. I can try 20 or 30 times to get coefficients that work well, and sometimes I cannot even get them at all. So we developed our own compensation software using the compass X, Y, and Z. And as you can see, we get perfect results. So again, it's a little add-on that we have as a company that is working very well for us. This is an example of a section of a final product that we had in Guinea. This was for an Australian company. As you can see, again, it's 0.2 of a nanotesla contours, which is amazingly high resolution. This particular data set didn't result in any mineable results, unfortunately, but it did indicate higher levels of gold as indicated in those high red zones, but not to the level that it was mineable. The associated client, the Turkish client to the side of this area, had much more successful results. There's our team up in Guinea after the end of the project. Not a very clear photo, but we have there 2 pilots, a party chief, and a data QC guy. That's in the remote areas, that's the normal size crew that we would send out. In the less remote areas, we go with the 2-man crew. That more or less sums it up. I think just to sum up where I'm going with this is, as I mentioned earlier on, mountains are the last unknown. They have not been covered very decently geophysically with airborne data, simply because of the height control problems. And long endurance drones, the bubble technology, height control, and low flying altitude has opened up a completely new horizon for exploration in these type of areas. And we're finding great demand for that type of work from clients. As I said, we've just opened an office in Canada. That's where I am speaking from at the moment. And the interest we're experiencing is really amazing. In the 1 month that I've been here, we've been approached by about 15 to 20 different clients already. So that's about all I have to say, guys. Any questions, you're welcome to ask.
Thank you, Trevor. Thank you a lot. And the first question from Helen. Which long endurance drones have you used?
Okay, we're using the Aurelia LE, which has 70 minutes endurance. 2 advantages: it's using the latest technology batteries. So for example's sake, with an M600, we're carrying 60 to 80 batteries with 4 to 6 charging points to keep the drone flying during the day. And it has 20 minutes max endurance with safety. With the Aurelia, we're carrying 7 sets of batteries. Oh yes, and with the M600 and a generator to keep the batteries charged. With the Aurelia, we take 7 sets of batteries, no generator, and it lasts the whole day, and we fly 3 times as much kilometers as the M600.
Okay, thank you. Next question from Robin. Is the bubble technology no-fly zones in UgCS? I'm not sure that I understood the question. Robin, if you can, please add some clarifications. And Syriac, Joseph Syriac, I believe that your question has been answered. Which is a high-endurance drone that you have used and the duration? Yes, I believe it has been already answered. One question from me, the same as for Jorge. What should be the first steps to start with airborne magnetics?
There's no question what the first step is, Alexei, and that is experienced crew. And please, please, please understand the logistical problems that you're going to be facing. If you're in a developed country, it's not too difficult. You just have to abide by the regulations. But if you're out in a country where there's no infrastructure, you better be very, very well prepared. It is not a simple task. You know, one of the obstacles we found, Alexei, is that clients think there's not so much recently, but up to about a year ago, you know, drones were considered almost like you can do it for a couple of $1,000s and it's almost a toy. The fact of the matter is that it's more complicated and more detail is needed than flying a fixed wing or a helicopter to complete a successful drone survey. Because you have a combination of need to traverse the ground as well as fly in the air and keeping the crew safe. So my absolute first advice is do not think you can just go out there and go do a survey. You better be experienced, you better be ready, and you better have everything under control and know exactly what you're doing. Otherwise, you're going to be facing a serious problem.
Okay, thank you for such an elaborate answer. And yes, some speakers missed the drone model. Could you please repeat it again? What was the drone model?
It's an Aurelia, A-U-R-E-L-I-A, and we're using the X6 Pro LE, which is it can lift 6 kilos, and it has 70 minutes endurance. With the mag arrow on, we're going for 40 to 50 minutes.
Okay, thank you. Question from Carol. Do you sometimes survey the same area at two different altitudes? Maybe you see difference of surface, close sources,
okay.
deeper sources that way.
That does happen, not very often. Normally the areas are very similar across the whole area, but it's a valid question. In one instance, we have done that. On the west coast, there's a desert that goes from the sea to about 10 kilometers inland, and then suddenly it becomes acacia bushes, which are about 8 meters to 10 meters high. We actually put a boundary along there, and we had 2 different fly nights.
Mm-hmm. Okay, thank you. Another question about height. What was the fly height on the Guinea project?
It was 35 meters.
55 meters.
35, yes.
35. Thank you. Line spacing is related to aircraft, and I suppose that was the question. What was the line spacing related to aircraft? And okay, what are the data frequency requirements for the base station?
Okay. The line spacing in Guinea was 100 meters, but we've flown surveys in South Africa at 10-meter line spacings, and we've actually done a small survey at 5-meter line spacings within a mine area, looking for a buried vehicle after a collapse. That's the first part of the question. What was the second part, Alexei?
The second one was, just a second, missed it already. What are the data frequency requirements for the base station? Okay,
the base station we're using a G859. Obviously, we place it conveniently, normally fairly close to where our charge point is. It's interesting to mention we normally don't move the charge point too often because it's quite an effort to uplift everything into the vehicle. So we normally use motorbikes, and we move the batteries from the charge point to the crew in the field via motorbike. The base station is monitored by the person who's controlling the charging. Normally the base station is about 100 meters away from the charge point, and he goes every half an hour or an hour when he has a chance to make sure it's still running correctly. And at the end of the day, it's all dumped at night, put onto our FTP, or if we have no internet connection, the QC is done in the field.
Thank you. Mr. Kwamena Jesus asks, a client have metal stamps in their stockpiles. Will magnetometer survey help identify these metals so they don't experience crusher outages? I believe that was to the topic that we were discussed.
Yeah, we discussed that with you a couple of days ago, didn't we?
Yeah.
We're going to be undertaking an actual test, walking the magnetometer over a known stockpile to see how effective it is. And if it works, we're following up with the drone technology. Again, a very interesting project. What effectively happened there, Alexei, the mine had a major collapse on the open pit. It buried all the equipment and it broke it all up. And now they have to clear out, it's 30 million cubic meters of earth.
Wow.
And it's all polluted with metal objects, etc. So the task is to find these metallic objects, and because it's getting thrown into the crusher and it's damaging the crusher. So we are busy with that right at this very moment. So it's a very interesting topic, to be honest with you.
Yeah, and the customer of ours use magnetometer, airborne magnetometry to identify terrain metals. We can't disclose the details now, but yeah, this topic is pretty hot right now, and certainly there will be more real life use cases on this topic.
Yes.
Okay, next topic, next question from Mr. Joseph Syriac. What is the depth of the prospects with MagAero?
With mag data, there's no depth limitation, but there's a fall off of frequency. Okay, so what happens is if you're looking for something that's mineable, it's normally within the top 200 or 300 meters at the most. So the lower you fly, the better you are. It's an exponential fall off, but at very low frequencies, you're actually reaching down to the magma. But of course, the width of your detection ability is probably a few kilometers wide at that point. If you're looking for small objects, you need to be as close as possible to the surface as you can. So generally speaking, the flying height is anything from 20 to 80 meters, depending on vegetation, tree height, etc., etc. The lower, the better.
Dr. Grace, one question for data processing. Do you apply, of course, depending on location, reduce to the pole and reduce to the equator, or only one of them? And I'll tell you why.
We produce the full data sets. Everything that's possible, we do.
Okay, because we've actually encountered some data close to the equator where we apply reduce to the pole, and it deviates, it gives us an inclination of northeast direction, which is not really proper. You've seen that, okay?
Yes,
so then you apply reduce to the equator, and then it actually goes properly. That's why my question, and you're an expert.
Yes, it's a very difficult problem. I know exactly what you're talking about. We experienced that problem. We had to develop a little bit of code ourselves to deal with it. The RTP near the equator, as per the standard equations within commercial software, doesn't work very well.
Okay, thank you so much, Doctor.
The next question from Katie De La Cruz. How about the equatorial dead zone?
Okay, the dead zone extends 3 to 5 degrees north and south of the equator, and it varies as you move away. The way that the previous generation sensors dealt with it is you had to angle the the sensor to hit the field at 90 degrees. So one of the big problems was that you could only fly in one direction, because when you came in the other direction, you had to alter the angle of the sensor. That moved on to self-changing sensors in the last 5 or 8 years, which helped the situation. And MagAero have dealt with this by having 2 sensors at 2 different angles within the instrument itself. And they combine these 2 results to produce a dead zone free signal. So what they've done is the little cube sensors within the MagAero, the one is sitting flat, the other one's sitting at an angle, and therefore they control the dead zone completely.
Okay, thank you. 2 questions linked to maximums. What is the maximum flight height, and what is the maximum speed at which you can collect data?
With the MagAero suspended underneath the drone, we can go up to 10 meters a second. What we found is if we go up to, say, 12 meters, we start finding that the oscillation becomes a little bit too much. We found the optimum speed at 9 meters a second. That's where we've settled at. If the wind is blowing, we can fly safely up to about 25 kilometers an hour of wind. Beyond that, the data starts getting compromised. So that's one limitation. Height-wise, there's fairly no limitation. The Aurelia can go up to, I don't know, 5,000 to 6,000 meters without any problem. With the M600, you just put high altitude props on to go higher, which has more bite into the air. It's a little bit harder on the motors, but it's no problem. So effectively, height doesn't have an influence on the drone per se. You would maybe need to fit high altitude props if you're at a very high altitude, but other than that, it's not too much of a problem. Now, if you go to the extremes, like you might find in the Andes or somewhere like that, where you're extremely high, you can still fly it, but I would look at the props and make sure that we've got high altitude propellers on the drones.
Okay, thank you. And I bet that would be the last question for today for all panelists. Is there a sensor that can find non-magnetic material like coal or graphite?
Yes, it's the electromagnetic system where you're measuring conductivity and resistivity. That's something we're working on. We're not marketing it too directly because the requirement from the ground side of things is still a little bit heavy. Hopefully within the next, but the results are magnificent. But hopefully in the next 6 to 9 months, we will have a ground system that's much more user-friendly and flexible. And then you don't need a magnetic object to actually detect it. You're looking at the conductivity, resistivity, and we are going to be at PDAC at the German pavilion. We are working in association with the German government and some German universities, and we are developing a new generation magnetometer sensor that samples at 10,000 hertz at 0.0005 nanotesla resolution. And we can concatenate them to have multiple sensors in a row. So we can actually have 20, 30, 40,000 hertz data. Then we can do ground-free airborne IP and airborne EM without any ground loop on the ground whatsoever. All we need is a base station on the ground. But we're going to be starting the test flights in a couple of weeks' time.
Thank you. Jorge, Yanis, in your opinion, what sensors can be used? Alexei, you also?
Alexei, you know that I'm not a geophysicist and not a geologist, so.
You are experienced drone guru.
Yes, I know how to carry magnetometer, and I know what it measures, but how to map measurements of magnetic field to the geological features, I don't know. I know how to find aircraft or pipe or UXO.
If you are speaking about geological objects or geological layers, then you need to figure out what properties are different for this particular thing you are looking and for surrounding rocks. If this is magnetic properties, you can use magnetometer. If you think that electrical conductivity probably is different, then you can use sensor that can measure what is the electrical resistivity of the ground. Or in the case of GPR, the electric permittivity. So you should always think about possibilities that you can measure and does those properties somehow can be related to your object. This is the way how you can approach it. And sometimes even if your particular object, for example, is not magnetic, if the surrounding rocks are magnetic, then you can map the area that is not magnetic and say, okay, then probably this is the place where it could be. So it's always like thinking about things that you can measure and trying to relate them to things that you want to find.
One of the biggest hurdles in geophysics is what just Janice said. Let's say you're looking for coal. Coal doesn't have a magnetic response, but it does have a structural behavior in certain areas in the world. So basically, that actually allows GPR to be effective, because if you're within 100 meters from surface, and if you have that host rock allowing you to transmit the waves properly so that you can control the noise to signal ratio, then you're able to highlight the seams at a certain depth. And that's what you're trying to do. For instance, when you're trying to, nowadays there's a big boom in Guyana for gravel, for aggregates. They need to find hard rock to be able to construct the roads. So we've had experiences in Colombia where we had to pretty much lay out the sterile layer from surface up to the hard rock and see the feasibility analysis for economical purposes of how much stripping you have to conduct. And GPR worked fantastic on that. So if you take that into any mineral, you just have to consider and analyze accordingly what mineral you're seeking, what is the actual depth analysis you have to actually pursue. And from there, just like Janice said, you're going to be able to be successful. You just have to make sure you correlate all the time with geology. And those boundaries, as far as horizons, it's going to have differences because you have the positional and structural differences that are going to be highlighted with GPR.
Thank you, Jorge. So before
Alexei, I want to comment just one comment about bubble technology. So can you share my screen for 1 minute?
Sure.
So yeah, it is a known issue actually when you need to fly at low altitude in the mountains usually. When you use standard terrain following algorithm in UgCS, here is cliff, and you can see that here distance to the surface can be dangerous, or especially here. It is how flight route or trajectory will be planned in the current version of UgCS. But in new version, it is actually internal beta version. It is still under test. We implemented something like bubble technology. So road tracer will try to keep not constant elevation above surface using vertical measurement, but constant distance to the surface.
Yes. Alexei, the problem, what you've shown me is quite correct and very useful. But the problem that we're facing is the actual terrain model itself is faulty. In other words, that's where we do the alteration. There's no problem with the flying height if the terrain model is correct. But it's taken from a vertical. So even the LiDAR at 2-meter accuracy, it's taken from a vertical. So if there's a bit of an overhang, you've got a shadow area underneath that overhang, which causes the problem. And if just by bad luck, you have one of your waypoints falling very close to that edge of where the overhang is, that's what happened to us where we lost our drone. So it's a problem of the actual terrain model itself, not the flying height per se, which is causing the problem. In other words, my opinion is, even though you've shown me a very interesting solution that UgCS have come up with, take it one step further and take that terrain model and assume it's incorrect. So you're going to be following a surface that is not being reflected properly, and you're still going to have the accident.
Yes, of course. Our new algorithm will work in case of more or less correct elevation model, of course.
Yes, no, of course. It's in the mountains and in the very steep terrains and gorges where these problems occur. It's not necessary to do the bubble technology everywhere. It's just in instances where you have very severe terrain.
Okay, thank you. Thank you, Alexei. Thank you, Trevor. The last couple of slides from me about magnetometers we use, and we offer together accurate magnetic data. It's Q-spin, Sensis Magdrom, and Geometrics Magarol. And yeah, they all provide you with higher sensitivity and resolution, high scan rate to eliminate drone noises, and also you can use through terrain following to fly as low as it possible. And for Q-spin sensors, we can use also in gradiometer configuration to find the smallest details possible. Yes. And the last thing for today, we are launching our demo flights in March and April. We are going to have them in Latvia, in the United States, Canada, and Australia. And we are going to demonstrate our sensors and our technologies, as well hardware and software. So you, all of you, will receive post-webinar email, and there will be a form for registration. Please secure your spot, and we'll be happy to see you on our demo flights.
Okay, thank you very much for the opportunity.
Yeah, and that's all for today. Thank you for coming. Thank you, our dear speakers, for sharing your experience. And
thank you for the opportunity.
Yeah, looking forward to seeing you again.